Hello everyone and welcome to this video on DBSCAN Clustering Algorithm by Intellipaat. We are going to understand this concept with the help of simple example. And this whole video is going to be very interesting, so just stay tuned with us till the end. The agenda that we have for this session is what is DBSCAN clustering, how it works, and at last we will implement it using Python and scikit-learn library. So by the end of this video, you will understand the complete concept of density-based clustering and how it creates clusters based on density that other algorithm cannot. But before we start, please make sure to subscribe to our channel and hit that bell icon for regular updates like this. So guys, as we all know, clustering is an unsupervised learning technique where we try to group the data points based on some specific characteristics. And there are various clustering algorithms with k-means and hierarchical clustering being the most used ones. But here, the issue with these two clustering algorithms is both k-means and hierarchical clustering fails in creating clusters of arbitrary shapes, and they are not able to form clusters based on the varying densities. And that's where we need DBSCAN clustering. So let's start with our first agenda point, that is, what is DBSCAN algorithm? So DBSCAN stands for Density-Based Spatial Clustering of Applications with Noise. So it is basically a density-based clustering algorithm that works on the assumption that clusters are denser regions in a space separated by regions of lower density. So what it does, that it groups densely grouped data points into a single cluster, and it can identify clusters in large spatial datasets by looking at the local density of those data points. And the most exciting feature of DBSCAN clustering is that it is robust to outliers, which means it does not require the number of clusters to be told beforehand, unlike k-means where we need to specify the number of centroids before. And this algorithm is mostly used for data analysis and pattern recognition. So there are two parameters that is required for DBSCAN algorithm. First one is the epsilon value. So it basically defines the neighborhood around any data point. That is, if the distance between two data points is lower or equal to the epsilon value, then they are considered as neighbors. And one way to find this epsilon value is based on the k distance graph. And the second parameter is MinPoints. So it is the minimum number of neighbors, or I can say data points, within the epsilon radius. So as the size of datasets increases, the number of MinPoints should also increase. So now let's try to understand DBSCAN clustering with this simple random data points that I have plotted here. So the first thing is to define the parameters, that is the epsilon value and MinPoints. So let's say I have taken MinPoints as 3 and an epsilon radius of value x for every data points here, right? And now with that parameters, first we have to define the core points, then the border points, and then the noise to that given data points, right? So let's say if I talk about the core points, they are actually the data points that contains at least MinPoints number of points around its epsilon radius circle. So let's say if I talk about this core data point, right? So as you can see that we have taken MinPoints as value 3. So in this epsilon radius, we should have at least 3 data points in this. So as you can see, we have 1, 2, this one, and 3, this one. These 3 data points were inside this epsilon radius. And same goes for this, you can see 1, 2, and 3. Here in this core point also, there are 3 minimum points. And like that, in all of these core points, you can see they are having at least 3 data points inside their epsilon radius. And that's why they are said as the core points for this given random data set. And next, if I talk about the border points, they are having the fewer than minimum points number of points around its epsilon radius circle. So here, border points are these two, yellow one, this one and this one. So in these two border points, they are having a fewer number of data points around their epsilon radius. So as you can see in this border point, there are 1 and 2. Two data points inside this data point, and here we have given minimum points as 3. So there are fewer minimum points present inside this border point. And same goes for this. There are 1, 2. Two data points present inside this border point. And last, if we talk about noise or outliers, they are basically the ones that don't have any other data points inside their epsilon radius. Or we can also say that they are the points which are neither a core point nor a border point, then it will be said as a noise. So here you can see we are two noise or outliers. This one, the red one, and this. So as you can see, inside the epsilon radius of these two data points, there are no other data points present other than that data point. So they are having only one data point inside their epsilon radius, this one and this one. As you can see, there are no more data points inside their epsilon radius, and that's why they are defined as a noise or outliers for these data sets, right? Now let us see what is density-based clustering. So density-based clustering is basically a method to form group or clusters in the data with a highly dense region of data points, that is separated with the other lower point density, which is marked as noise or outliers. And if we talk about the DBSCAN clustering algorithm, it is the base algorithm to this density-based clustering. So as you can see in the figure here, how two clusters were formed according to their higher density. And the rest data points, as you can see, which are marked in gray, they are having a very low density, and that's why they are marked as noise or outliers to that data set. Now let us see how DBSCAN clustering actually works in a proper step-by-step manner. So the first step is parameter selection. So as I said before, we need to pass two parameters, that is epsilon value and min points, before we start with DBSCAN clustering algorithm for any given data set. So that is going to be the first step in DBSCAN clustering algorithm. Now coming to the second step, it is to identify the core points in the given data set. So as I said, core points are the ones that are having at least min points number of points within its epsilon radius, right? So we have to find the core points in our given data set, and that is the second step. Then the third step is to find the border points, or we can say directly density reachable points. So they are the ones which are having fewer number of min points, but they are the neighborhood of a core point. And coming to the fourth step, it is to form a cluster by connecting core points and their border points. And if that core points has no border points, then label that point as a noise or outliers. And next, step number 5 is to expand these clusters by visiting the unvisited data points by finding the border points and adding it to the existing clusters. And the last step, number 6, is to identify the noise by labeling any remaining unassigned data points as noise. So they are basically neither the core point nor the border point for any core points. So by that, they are identified as noise. So as the diagram on the left, you can see how clusters are getting formed where there is high density, and low density points are how getting identified as noise. So you can see all the red dots are forming one clusters, blue are forming another clusters, then green and yellow are forming another clusters, and rest are defined as noise for that data set, right? So as we have seen what DBSCAN clustering is and how it actually works, now let us see the implementation of DBSCAN clustering using Python. Okay guys, so now I am here at the Google Colab notebook, and first of all I have imported all of the necessary libraries that were needed for the implementation. Like I have imported NumPy, Pandas, Matplotlib, and I have also imported math library to basically plot a simple data set here. So let me run this first. And like here, I have used math library. So here basically I'm creating a sample data set with two features so that we can visualize it easily. So for creating the data set, I have created a function called points in circum, which takes the radius and number of data points as arguments and return an array of data points which then plotted in a form of circles. So we are doing this with the help of sine and cosine curves here. And then here, as we know, one circle won't be sufficient to see the clustering ability of DBSCAN, right? Therefore, I have created 3 concentric circles of different radii. And also, we are going to add noise to this data set so that we can see how different types of clustering algorithms deals with this noise, right? So now, here I have plotted my sample data set. So let's run this. So as now you can see here, this is the sample data set in which we are going to perform our implementation of DBSCAN clustering, right? Okay, so before we implement DBSCAN clustering and see how it makes clustering in this sample data set, let us first see how k-means and hierarchical clustering makes clusters in this given sample data set. So starting with k-means first. So for that, we need to first import k-means from the sklearn cluster library. So we will write here from sklearn.cluster and then import k-means. And I will run this. Now, as we have imported our k-means clustering algorithm, now let's first create a variable here. I will write k-means equals to k-means here. And then we have to pass the number of clusters and a random state. So I will pass here number of clusters as 4 and I will give a random state of value 42. So let us write that. I will write n underscore clusters equals to, I will pass 4 here and then I will pass a random state. So I'm giving a random state value of 42 here. Right? And then we have to fit the data frame to this k-means clustering. So we will write here k-means and then fit data frame and we will pass here 0, 1. Now let us run this. Okay. So as we have implemented k-means and we are also fit our data to k-means, now we will retrieve the labels from the data set using labels underscore. So for that we will write here data frame and then we will pass here colon k-means underscore labels, right? And then we will give here k-means dot labels underscore. So we are going to retrieve our labels from the data set using this. So let me run this first. Okay. Now we have to plot this and we'll see how k-means clustering forming clusters in this given sample data set. So let us plot this now. So first of all, we will write our colors. So here we have to pass 4 colors as we have given 4 clusters. So we have to pass 4 colors for that. So I am passing here purple, red, blue and green. So I have passed the 4 colors here. Then we have to plot the figure. So for that we will write here plot dot figure and then we have to pass the figure size here. So I will pass the figure size equals to 6,6 and then we have to plot our scatter plot. So by plotting the scatter plot only, we can see how our data points were plotted in the scatter plot and how k-means clustering formed the clusters in that data points. So let us plot our scatter plot here. So for that we will write plot.scatter and then data frame. We have to pass the value 0 here. Then data frame, we have to pass value 1 here. And then we will write c equals to data frame. And then the same thing that we have written above here, k means this, k means underscore labels. And then here we will write cmap. Cmap equals to matplotlib dot colors. So here we are passing this because as we have listed above the 4 colors, so we want our clustering to be done according to that given colors. So we have to pass this here. We will write here colors dot listed color map, and then as we have given in our variable name colors, so we will pass our variable name here, that is color, right? And then we have to pass the size of that data point. So let us give the size of that data points 15. And then we will give a title to our scatter plot. So I will write here plot.title and we'll give it title k means clustering. And then we have to pass the font size for that. So I will pass here 20. And after that, let us give the labels for x and y axis. So first of all, let's give label for x axis. I will write here feature 1. Feature 1. Then the font size for that. And then we will give the name for our y axis. I will give here feature 2, and then we will pass the font size same. And at last we will write here plot.show. So this will give the output, or this will give the output of our scatter plot. Now let us run this and see how k-means clustering is making clusters in this given dataset. So as you can see how k-means clustering is forming clusters in this given dataset. Right, you can see that k-means is unable to form an arbitrary cluster here, and in this way it is forming 4 clusters. Like this is the red cluster here, this is the green cluster, this is another purple cluster, and this is another blue cluster. And this k-means is also unable to find noises in this given dataset. Like these are all the noises for this given dataset, but k-means clustering is unable to find that noises and included that noise points also inside these clusters, right? Now as we have seen how k-means clustering forming the clusters here, now let us see how hierarchical clustering will form clusters in this given dataset, right? And now for hierarchical clustering, we need to first import that, right? So we will import agglomerative clustering. As you all know, it is one of the type of hierarchical clustering, right? So we will import that from sklearn.cluster. So let us write that sklearn.cluster and then import agglomerative clustering. So agglomerative clustering is one of the type of hierarchical clustering. So we are going to perform our hierarchical clustering with agglomerative clustering. So I'm importing that. And once we import that, let me run that first. Okay, it imported. Now we will write here model equals to, we will pass agglomerative clustering. And then I have to pass number of clusters and affinity to that. So let me pass first number of clusters. So I will give here number of clusters as 4, right? And then I will pass here affinity. So affinity equals to, I will pass Euclidean here. So Euclidean is basically a technique to find the distance between 2 points. So it was basically used in hierarchical clustering to find the distance between 2 points. So yes, there are other methods also to find the distance, but here I'm using Euclidean distance. So I'm passing here Euclidean. And after that, I will write here model and fit this data frame to this agglomerative clustering model, right? And now here I will write model.fit to fit our data frame to the agglomerative clustering model. And then data frame, I will pass here 0, 1. Now let's run this. Okay. Now we have to retrieve our labels from the given data sets. So we will write here data frame and then HR underscore labels. So this should be inside column. And then we will pass here model dot labels underscore. Labels underscore. Right. Let's run this now. Okay. So now we are going to plot our scatter plot and we'll see how hierarchical clustering is actually forming clusters in this data set, right? So let us plot that. We will write here plot figure and we will pass here figure size. Figure size, I will pass 6,6 and then I will plot the scatter plot. So as I said before, we are plotting scatter plot to actually see how actually our agglomerative clustering or hierarchical clustering is forming clusters in the given sample data set, right? I will pass here 1 and then we have to pass C equals to data frame and then we have to pass the same that we have passed above, that is HR underscore labels, right? This should also be inside column and then I will pass here CMap. I will write matplotlib dot colors and then the listed colors that I have passed, listed color map, and then colors here, and the same we have to pass the size of our data points now. So I'm passing here 15 and now we will give the title to our scatter plot. Now I am giving here hierarchical clustering. I will pass the font size and then X and Y labels. So I will write here feature 1 font size equals to 14 and then I will pass the Y label. So I'll copy this, paste here. I will write Y label and I will change it to feature 2, right? And at last we have to show this scatter plot. So we will write here plot.show. Now let's run this and see how hierarchical clustering is actually forming clusters in this. Okay, there is an error. Matplotlib here. And then here is an issue. Okay, it's figure size. Now let's run it again and see. Okay, there is another error. Let's see what is it. HR labels. Okay, it should be small l. Let's run it. Okay, so now you can see how hierarchical clustering is forming clusters in this given data set. So you can see this is one cluster that hierarchical clustering formed here, and rest you can see how it formed. Hierarchical clustering is also unable to form clusters in the arbitrary shape. You can see it forming this as one cluster, this as another cluster, this red one as another cluster, this green one as another cluster. And as you can see, hierarchical clustering is also unable to find noise in these given data set. Like these are all the noise in our data set, but hierarchical clustering is also unable to find these noises in this data set, right? So now it's time to see and implement DBSCAN clustering algorithm and see its actual power. So for that, let us first import that. So I will write from sklearn.cluster and I will import DBSCAN. Right, so let's run this. Okay, we have imported DBSCAN now. And now we will make a variable here. I will write DBSCAN equals to, and I will pass here DBSCAN that I have imported. And here, as we have discussed, we have to pass the two parameters, that is epsilon value and minimum samples. So let us pass those two parameters here. So I will write EPS equals to 30 and then minimum samples I will pass here 6, right? So these are the two parameters that need to be passed while we are working with DBSCAN clustering algorithm. And then we will fit this to the data frame here. So I will write here DBSCAN fit, and then we will fit that to our data frame. I will pass here 0, 1. So now let's run this. Okay, we have fitted our model to the data frame, right? Now let's retrieve our labels from the data set. So we are going to use labels underscore for that. So I will write here df data frame, and then I will write dbscan underscore opt underscore labels, and here I will write dbscan dot labels. So we are retrieving our labels. So sorry for that, it's dbscan dot labels underscore, right? And then we have to write here, okay, let me copy this and paste the same here, and here I have to write dot value underscore counts. So we are actually counting the values here, right? Now let me run this. Okay, so here we got the output, the value counts and all. And now let us plot this and see how DBSCAN is actually forming clusters in this given data set, right? So I will write here plot dot figure, and then I will pass figure size here, and I will pass 6, 6. Okay, and then the same we have to pass scatter plot here. I will write plot dot scatter, then data frame 0, data frame 1, and then here we will write C equals to data frame, and then we will write here this DBSCAN opt labels. I will copy that and paste it here, and then I will write cmap equals to matplotlib dot colors dot our listed colors, right? So listed color map, and we will pass here colors, and here I have to pass the size of data points, right? And after that I have to pass the title of the scatter plot, and then I will give the title as DBSCAN clustering here, and then I have to pass the font size I will pass 20, and then we have to give the x and y labels. So first I will pass x label, so it will be feature 1, then font size, right? So I will copy that, paste here, y label, and I will change it to feature 2, and at last we will show this plot. So we will write here plot.show. So here it will be figure size equals to 6, 6. Right? Now let's run this part and see how DBSCAN clustering actually forming clusters in these given sample data sets. Let's run that. So here you can see the magic. How DBSCAN is actually making clusters here. You can see the first cluster that DBSCAN is forming is this green color in the arbitrary shape. And the second cluster, as you can see, the blue one in this arbitrary shape. And the third cluster in this red color. And you can also see the noises that were in the purple color, right? So you can see how properly DBSCAN cluster actually formed a clusters in this data set. This arbitrary red cluster, this arbitrary blue circle, and this is the green arbitrary circle. And there are some noise points in between these clusters also. So you can see how properly it actually formed a cluster in this data set. And this is how DBSCAN actually formed cluster. And if you see, this is how hierarchical clustering formed clusters. So you can see this is not the proper clustering that has done in this data set. And same goes for this k-means clustering. This is not the proper cluster that should have formed, right? So that is the magic. That is the real magic of DB clustering, of forming clusters in this arbitrary form, right? So that's all we have for this video. I hope you got a good understanding about what is DBSCAN clustering, how it actually works, and how to implement DBSCAN clustering with the help of Python and scikit-learn library. Thanks for staying with us till the end, and if you found this video helpful, please give it a thumbs up and share it with your fellow mates. Also, make sure to subscribe to our YouTube channel so that you won't miss any updates coming from our side. Thank you so much.
Just a quick info guys, Intellipaat offers machine learning course in collaboration with IITM Pravartak. Through this course, you will learn various algorithms and machine learning techniques such as supervised, unsupervised learning, natural language processing, and much more from the IIT Madras faculty and industry experts. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel, whose link is given below in the description. Without a doubt, this course can set your career to new heights. So visit the course page given below in the description and take a first step towards career growth in the field of machine learning.